Timmelkamp besteht seit 1900.
Timmelkamp was founded in 1925, and power is our core business, including power generation, distribution, and grids. Environmental protection has actually been at the forefront for us since the very beginning. We are especially proud in this regard that we were able to build a power plant with an efficiency rating of almost 60% and especially low nitrous oxide emissions. Balancing power will continue to play a major role in the future. By balancing power, I mean balancing out the fluctuations caused by renewable energy sources.
Boiler circuits are an important component in power plants. Electric motor-driven pumps transport water into the boiler, where it is heated up by the gas turbine exhaust. The steam produced in this way is conducted through a steam turbine that, together with a gas turbine, drives a generator that produces electrical energy. Because of the high backup reserve requirements, even baseload power plants always operate with throttled boiler feed pumps. Experience has shown that the conditions and requirements for modern combined cycle power plants have changed. Many power plants that were originally designed as baseload stations are later operated under partial load, because they must be able to balance out the fluctuations caused by renewable energy sources. This flexibility will become more and more important as time passes. The flow volume is varied in the boiler feed water supply circuit in order to meet changing energy needs. There are currently 3 ways of doing this in practice. Discharge throttling is similar to a garden hose, with the flows reduced by gradually closing the nozzle. This increases the water pressure in the hose. While the pump speed remains constant, a throttle valve in the feed water circuit generates resistance in order to reduce the flow volume. The result is increased pressure in the water supply line. In addition, it drastically reduces the hydraulic efficiency of the boiler feed pump. At the same time, the throttle valve experiences wear through cavitation, resulting in the expensive proposition of replacing valves along with a high level of vibration-induced noise. Energy waste, high maintenance costs, and inadequate reliability make discharge throttling a poor choice for modern power plants. Another alternative to throttling is to regulate the flow volume by controlling the pump speed using variable frequency drives or variable speed fluid couplings. However, the high number of parts in a variable frequency drive increases the failure rate and reduces reliability. Controlling pump speed using Voigt hydrodynamic couplings, which feature outstanding energy savings and high reliability, is a significantly more economical solution. The hydrodynamic couplings integrated oil system supplies the bearings of the boiler feed pump and the electric motor with lubricating oil. A separate lube oil supply system is now no longer necessary. The principle of hydrodynamics is based on using oil to transfer the power coming from the motor. There is no mechanical connection between the motor and the driven machine. This ensures a wear-free power transmission. At the same time, the oil serves as a damping medium, filtering out torsional vibrations and torque peaks. This increases the service life of the entire driveline. The pump speed is controlled by the oil fill level in the coupling. This is done using a scoop tube that extends or retracts in order to change the fill level. A 4 to 20 milliampere signal is all that is needed to control it. This makes integrating it into the power plant control system a simple matter. Its robust construction makes the Voigt variable speed coupling ideal for outdoor use and deployment under extreme climate conditions. Using variable speed coupling also yields tremendous energy savings. Energy savings of up to 2.5 million kilowatt hours per year can be achieved even in baseload power plants with a 420 megawatt block output. That's enough energy to supply 600 homes with power for a year. Under partial load operations, the savings are even greater. Thanks to its compact construction and integrated oil system, the Voith variable speed coupling requires significantly less space than a variable frequency drive. In addition, their unsurpassed reliability makes Voith variable speed couplings a convincing choice. They require no power electronics, for which there are usually no spare parts available after just a few years. Voith guarantees replacement part availability for the entire service life cycle, with service available anywhere in the world. We're always nearby. More than 1,000 machines are in use in combined cycle power plants around the world and have been demonstrating their reliability for 40 years, something more and more of our customers have come to trust. Voith, engineered reliability.